Waves produced by the oscillations of electric and magnetic fields. Electric and magnetic waves vibrate perpendicular to each other as well as normal to the direction of their propagation. Modulation. It is a technique by which some characteristics of the carrier wave are varied with time in accordance with the modulating signal. The higher frequency wave having constant amplification and a fixed frequency is called carrier wave, whereas an audio signal is called modulating signal. Mathematically, VCT equals a sin 2 pi FCT plus phi, where OA, amplitude of the carrier wave, OFC, frequency of the carrier wave, O phi, phase angle. There are three types of modulation: O amplitude modulation, O frequency modulation, O phase modulation. Amplitude modulation A, M. In amplitude modulation, the amplitude of the carrier wave is varied in accordance with modulating signal voltage. Frequency modulation F, M. In frequency modulation, the amplitude of the modulated carrier wave is kept constant, but the frequency of it varies in proportional to the amplitude of the modulating signal. The frequency of FM transmitter without any modulating signal input is called center frequency or resting frequency. The frequency of FM transmitter with modulating signal input is called frequency deviation, and total deviation is called carrier swing. FM broadcast transmitters operate at frequencies of 88 MHz to 108 MHz. Percentage of modulation P, M. It shows the extent to which the modulating signal modulates the carrier waves. If modulation is symmetrical, then percentage of modulation is M equals BA times 100. Physics by Bilal Zia. Physics, ECAT and MD-CAT. 121 PAGE, compiled by Enger. M. Bilal Zia. Where OB equals amplitude of modulating signal, OA equals amplitude of carrier waves. Sidebands. A sideband is a band of frequencies higher or lower than the carrier frequency and carry the information, i.e. intelligence signal. Demodulation. The process by which the original modulating signal or intelligence is recovered in the radio receiver is called detection or demodulation. Energy band theory. The fundamental electrical property of a solid is its response to an applied electrical field, i.e., its ability to conduct electric current. The electrical behaviors of various materials are diverse. Some are very good conductors, e.g., materials with conductivities of the order of 107 ωm-1. At the other extreme, some solids, e.g., wood, diamond, etc., have very low conductivities ranging between 10 to 10 and 10 to 20 ωm-1. These are called insulators. Solids with intermediate conductivities, generally from 10 to 6 to 10 to 4 ωm-1, are termed semiconductors, e.g., silicon, germanium, etc. Valence band. The electrons in the outermost shell of an atom are called valence electrons, and the energy band occupying these electrons is known as valence band. It may be either completely filled or partially filled with electrons and can never be empty. Conduction band. The band above the valence band is called conduction band. In conduction band, electron moves freely and conduct electric current through solids. That is why the electrons occupying this band are known as conductive electrons or free electrons. Any electron leaving the valence band is accommodated by this band. It may be either or partially filled with electrons. Forbidden band. The energy gap between the valence band and the conduction band is called forbidden band. These are normally completely filled and no electron of them takes part in the conduction process. Types of solids. On the basis of electrical conductivity, solids are classified into three types: O conductors, O insulators, O semiconductors. I conductors. Since in conductors there are large number of